Okay, a curve C has parametric equations x equals 2 sine t and y equals 1 minus cos 2t. Find dy by dx at the point where t equals pi over 6. So find the gradient at the point where t equals pi over 6. So the first thing that we're going to want to do is differentiate both of these with respect to t. So x equals 2 sine t. So dx by dt equals, well, the derivative of sine t is cos t, so it's just 2 cosine t. Okay, so y. I'd really like to have this angle in terms of t rather than 2t, so what we're going to do is use the double angle formula, that cos 2t is equal to 1 minus 2 sine squared t, and then plug this into y. So y equals 1 minus 2 sine squared t. So I've just replaced cos 2t with 1 minus 2 sine squared t here, which gives us y equals 2 sine squared t. 1 minus 1 is 0, and this negative and negative cancel out to give us a positive. So let's differentiate this with respect to t. To make this easier, sometimes I like to think of it as sine squared t is the same thing as sine t squared, because it is the same thing. And then this just gives us the clue that we need to use the chain rule here to differentiate this. So dy by dt is equal to 2 times 2 is 4 sine t times the derivative of sine t, which is cosine t. So how do we find dy by dx? This is what we're trying to find. Okay, so dy by dx is equal to dy by dt times the inverse of this, which is dt by dx. You can kind of like to think of these guys as cancelling out with each other, giving us dy by dx. So dy by dx is equal to 4 sine t cos t times 1 over 2 cos t. So the 4 and the 2 cancel, leaving the 2 here, and the cos cancel. So this just gives us 2 sine of t. All we need to do to find the answer is to plug in pi over 6 as t. And this should give us a value of 1. There we have it. That's part A of question 4, June 2013.